Welcome back in Generals to another Let's Fix Generals a 0 hour to make the best game ever. Good. Last session we were exploring oversizing the terrain, which caused stalling and visual glitching. The usual, yeah. So the question is, I think we first need to investigate the glitching and then the performance degradation. Or the other way around. Doesn't really matter, I guess, but Okay, right now I have no clue for either of the issues. Regarding performance, we could maybe create a recording in here. CPU usage. Maybe this will help us identify the problem. Let's see. We go skirmish. No, yeah, skirmish. Yeah, okay. So the lag still happens. The lag still happens. So if we create a recording here, record CPU profile. Let's do that. And then we do this. Okay, let's see if that gives us anything interesting to look at. Do the light. Let's see. Can we see like one specific spike? The problem is we don't have any frame times. We don't know where a frame is here. Yeah, how do we identify one frame? I don't know. Events. Let me search Visual Studio CPU profiler markers. Records. It's probably a very basic profiler. Yeah. External code. Let me ask ChatGPT. within Visual Studio, within Visual Studio 2022 is a CPU profiler. Is it possible to add custom custom markers for it? For example, game frame begin and end markers. Searching the web. Custom marker, yes, please. Good question. Short answer is yes, at least in recent versions. You can add custom markers, user marks. But that's C#. C++, there we go. User marks emit. Okay, cool. For native C++, include user marks. User marks emit. Event happened. Start, code, end. User mark range, start. Event happened. Just pause points or ranges. Profile by frame breakdown. Probably yes. Okay, so it is possible. Maybe that's something we can do. Yeah. Okay, let's see without this for now. What is this here? Do the lights. Oh, that looks expensive. Can I zoom in here or there? What are these points here? Huh? What? Here, oversized terrain. There we go. Can we see? Can we find all view in call tree? Can we see it for all? Where's the what the hell? Where's the yeah. Okay, how do I select all? Here. Can I search for a function here? Oversize. Here. Could not find any matches. Well, that sucks. Okay. Oversize terrain. There we go. Okay. What? Ugh. Why can't it just show me the function? What is this? Double click a function. Oh, do I have to go now down here? What is this? Huh? Game engine update. Why can't I just find the terrain? Ugh. Okay. Iterate drawbacks in region. That is quite expensive. Set camera transform. Whoa, that is very expensive. Ah, because that's where update terrain happens, which is where this happens. Ah, there we go. Okay. Okay. So update block is expensive and oversized terrain. Update center looks pretty cheap. That's nice. Okay, update block. Update VB. Okay, so these things are very expensive. Okay, let's see what is so expensive in here. Init height data. Update block. Okay. Update VB. Do the light. Okay, there's a lot of expensive stuff here. Oof. 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 Update VB. Oof. Operator new. Oh. Init height data. Oof. Oof. Okay, so update VB. Let's take a look at that. Update VB. Oof. Can we also see like view and flame graph? Oh, there's a flame graph. Oh, that's nice. Why? Okay, that actually is not bad. That is not bad at all. It's just that it's a bit inconvenient, the visualization, but it's not too bad. Yeah, we even see this here. That's nice. Okay, we can work with that. Update VB. Okay, so what is expensive in here? This one, alpha UV data. Yeah, it looks like a death by 1,000 cuts in here. Yeah, it's a lot of small things. What's a long? No, here's the end. There's a lot of small positions in here. I suspect it's just the volume of things it needs to do. Yeah. Oof. Update VB. Update center. Oversized terrain. Yeah, so here's the offender. So oversized terrain is a big position and update block. But update block update block is probably just yeah, hold on. Update block. Update block. Yeah, well, it could be part of this one here, yeah. But it also does update block here. Yeah. Yeah, there are many code paths that call this. Yeah. Okay, this could be just a reoccurring cost that happens all the time anyway. Yeah, I think we mainly need to focus on this one here. Init height data. So okay, it also calls update block here. There's some cost on allocations. Allocations update block, which calls update VB. Do the light, get alpha, cross product. Init height date. Okay, refresh shroud is also expensive. Refresh shroud. Why do we need to call refresh shroud? Maybe it's possible to skip this one here. I don't know. Maybe. Okay, so certainly the biggest cost is here in update VB. And I think it's simply the huge volume of things it needs to do. Update VB. So there's a loop down here, y0, y1, and I suspect that's just a huge number. Update VB. What about x0, x0? Ah, there's a subloop here. Okay, I see. Okay, so yeah, I see. Female control. Oh. So update VB. There's a lock class, lock vertex buffer. I don't know. It's just doing a lot of things in here. It's not trivial to optimize this. We could put it maybe on other threads and just process this on the side. I'm not sure. How big is this data? Maybe another angle of this would be to keep multiple copies in memory and just swap them then their usage. So you prepare different area sizes and then you just keep them always hot in memory. Maybe. Instead of loading it again. Where's the code? Update VB. What is it updating? We have been building the vertex buffer in the memory location. Now copy the set of vertices into the hardware buffer. We don't copy the whole vertex buffer because we often update only a couple of rows. And it's a lot faster to just copy the ones that change. Vertex buffer in the memory location. Copy the set of vertices into the hardware buffer. We don't copy the whole vertex buffer. Okay, that's a problem. Mem copy. Oof, that's another. That's a small loop though. Okay, that's interesting. So it basically builds a mesh and then it copies it into the GPU. Update the rectangular block of the given vertex buffer. Data is expected to be an array same dimension as current height map, mapped into this VB. Okay, so it only copies. Okay. Okay, I have a rough idea of what this thing is doing. Um, hmm, hmm, hmm. Yeah. It looks like it's a volume of things it does. The sheer amount of tiles that we want to show that we have to go through. Like the things are evenly distributed here. Get UV data, get display height, get X, get Y. We can probably do some savings. Get UV data. Why is this so? Get UV data. Get UV data. Okay, so these two, interestingly, the positions here, they show much different than here. Like if we look at this guy here, like this is the whole time spent in it, right? And so this one looks to be like, I don't know, 15% of it. But here it only is labeled as 0.1%. Okay. And so So why is this so expensive here? What is it doing? Oof. Okay. Okay. I see. I see. Ooh. Get alpha UV. Ooh. Get the texture coordinates to use with the alpha texture. X, Y, the integer coordinates into the height map. U and V are the texture coordinates for the four corners of a height map cell. Full tile is true if we are doing 1/2 resolution height map and require a full tile. The texture is otherwise we use quarter tiles. Flip is set if we need to flip the diagonal across the cell to make the alpha coordinates blend properly. Filling a square with two triangles is not symmetrical. Yeah. I wonder if we can pre-compute this already. Like do one pass where we have it ready. Yeah. Oh boy. Yeah. What does it give? Flip triangle. Need flip. Get alpha UV data. So this is out, yeah? Flip. Full time. So I guess this is out, this, and this. Alpha UV data. And this out. So these four are out, I assume. Yeah. Yeah, maybe. Okay, so these two things would need optimizing. Let me take some notes here. So optimize these two. What else? CPU usage. There we go. So that would, we can probably get these positions here smaller. Okay, what else? Cross product. Where is it? This one? This one? There's another cross product. Normalize. 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 Okay, so that is slow as well. Vector 3 normalize. Taxa. So we have 1, 2, 3, 4 normalizations in here. Normal at Texel. Normal at Texel. Can we optimize this? Do the light. Normal at Texel. Normal. L2R, what is this? Display height, get display height. Well, we can also pre-compute these, I guess. Yeah. Pre-compute. And then we can also pre-compute these normals, I guess. Yeah. Poof, that would be quite a bit of work. So we pre-compute this. Yeah. So this will be always the same, right? So 2 times this, blah, blah. So, oh god. Oh god. That's kind of just oh boy, what is this? UN 0. Top left sample. Top left sample. Normal at text. What is that used for? For lightning. Oh boy. So I think we can do it. We just need to find the correct bounds. I guess just over all height map data, I guess. Yeah. What is this set? What is this function? Good. Good. Let's get back to CPU usage. So we have this guy. So these three we can pre-compute, which is already 50% of the whole thing. Do the light. What about this one? Do the light. Do the light. Oof. Yeah. Only the first terrain light contributes to ambience. Height is below water level. Blah. Okay, so this is a lot of computation here. Oof. Global data. Red, green, blue. Calculates diffuse lighting for a vertex in the terrain, taking all of the static lights into account as well. It is possible to just use the normal in the vertex and let D3D do the lightning. But it's slower to render and can only handle 4 lights at this point. Can we... light. Do the light. Lights it. Do the light. I do not have a good idea for this guy. What we can do here, a shader, clamp. can we do in there? 2 lights, let me... Oh shit, no, I touched it. So dot product is expensive. Right, it right. What is this function doing? Oof, that one we should cache. CPU usage. So it does spend time here with get X with origin and get display height and shit like that. Get Y with origins. Yeah. Yeah. I think the repeating calls here, this one can be optimized, yeah. Get X with origin. Get Y with origin. Because this function is not particularly cheap, right? There are multiple conditions in here. Yeah. I think we will get some nice performance gains with this. This is a low-hanging fruit. So here we can do... what is this? Int const int jy with origin. I don't know what to call it. Y with origin. Get Y with origin. Get Y. What does it mean, get Y with origin? Gets a Y index that corresponds to the data. For example, if the rows are shifted by 3, index 3 is actually the first row of polygons, or 0. What? Yes, it is confusing, but it makes sliding the map 10x faster. What? Gets a Y index that corresponds to the data. If the rows are shifted by 3, index 3 is actually the first row. think we can cell offset. Cells. Okay, I think what we only need to do is y with origin at j. How about we do that? Y with origin at j. What about x with origin? Oh, that's a die. Okay, well then we just do y with origin and x with origin. Okay, then we replace all of these with get x with origin. Update VB for light optimized. X with I think here we can do the same. Constant y with origin. Get y with origin j. Constant x with origin. How about it? I think maybe that's a bad name. Maybe we should just call it. Maybe we should call it. How about we call it X data index? X data index. Get X with origin I. X with Y with origin Y data index. Okay, and then this one we can also so here we have X with origin. This one will be moved down here. Then this X with origin we rename to data index, X data index. There's another one here. Const y data index. Const X data index. Get X with origin I. Okay. Okay, that has worked, and then now we take this guy and we rename him to Y data index. Okay, here we have another one missing. Const int Y data index. Equals that. Y data index. Oh, there's more. My gosh. This one needs to be moved up. Okay, so if I didn't make a mistake, then this should be all good. Yeah, X data index, cell offset. Yeah. Could also name it Excel maybe. Yeah. Excel. Why cell? Or let's say cell Y. How about that? Cell Y. Oh, that already exists as a name. Maybe we call it map Y, map X. We could do that. Map Y. To X, map X. Okay. Okay, let's see. No, let's not stop debugging yet. So that is that. So we have now optimized this one here, this guy and this guy. There is get display height. That also. Let me take a look at that. Get display height. Okay, but this is always different. Yeah. Yeah. Yeah, I think this one we cannot easily optimize because it always accesses something else. This one probably is data. Yeah, this one is data bound. Yeah. Yeah, here we can't do much unless there is some case where it accesses the same thing twice. But it's hard to tell here. They all look very different. Yeah, no, I think there's no optimization opportunity here. Okay. Yeah, so we can optimize this and this and this, and maybe this helps a lot. I don't know what to do about the do light. Lower size terrain in at height. And then there's also the shroud thingy. There's also, interestingly, delete and new. New delete. Yeah. Okay, what is it doing? Where is it allocating? This one. I guess it's this one here. Maybe. Where's this deletion? Free index vertex buffers. Oof. Oof. Freeze resources used to draw the terrain. Free index vertex buffers. Free index vertex buffers. Index vertex buffers. Free index vertex buffers. Why is this so expensive then? What is this? Okay, that's weird. So the shroud level, oh man, there's so much expensive shit in here. Man. Is there anything we can do with this here? Operator new and delete. Why? Why is this so expensive? Allocate bytes, do not zero. Here, new. But I think we... I think I put a breakpoint in here and it didn't actually hit, right, this year. Last session. This is the expensive one, but why? Why is this expensive? It's only one allocation. Was there a loop? Missing something? Need to allocate. Why is this so expensive? This one is probably, I don't know, 15% new and deletes of this whole thing. Why is this so much? This one, I'm confused. Here's another new. Okay, but there's also not in a loop. But this one apparently is expensive. There's a loop. Okay, how many tiles do we have? NumVB. Okay. Okay, I see. I see. Okay. I see. Okay, there are a lot of allocations and freeze. Okay. How can we optimize this? Okay, right now I don't have a good idea here, other than not freeing it. Vertex buffer backup. Vertex buffer. Why do we need to free it? Free vertex buffer, index buffer. Free index vertex buffer. Requested height map differs from old one. Create static index buffers. Can we maybe say we only reallocate when it grows, but when it's smaller, we just use an existing range from these buffers. But it also uses here as an argument. Okay, but it is this one that is so expensive. Well, this one also has some cost here. But this one is the most expensive, probably because this one is the largest. This one is a small allocation, and this one is a pretty sizable one. Yeah. Yeah. Vertex buffer tiles. If the size changed, we need to allocate. Okay. I would like to take a break here. And then next session we continue with this. Yeah, we need to bring down the costs. Though there's really a lot of stuff here. Like, I don't know. This will be a lot of work. I hope I can get rid of this shrouding here somehow. Fresh shroud. I don't know. Probably needs refresh. Yeah, it's really a lot of shit it does here. Yeah. Good. Take a break here. Wish you a great day or night. Until next time. Goodbye.